about odd and evenness. Primarily, when we plug in an even or odd number, do we get an even or odd number out? What does that end up looking like? So we start with primary definitions, which is an even number is 2k, an odd number would be 2k plus 1. And an additional piece here that we need to make sure that we include is that we're identifying k as being some integer. Doesn't really matter what integer, positive, negative, 0. It's just as long as k is an integer. If k is not an integer, then we start running into situations where the results are neither odd nor even because they're some type of non-integer rational value. So this is our definitions for even and for odd. We take any number we multiply by 2, we make it even. We take any even number plus 1 and we make it odd. And that's exactly what we're doing here. So we have even plus 1, which always is going to be odd. We could also do this by 2k minus 1, and we end up in the same place. So, well, now what? Well, let's look through an example. Is 4a plus 1 even or odd? Okay, odd or even, either way. I guess I just make that proper English, right? So let's start with case 1. Let's say that a is equal to an odd number. So that's 2k plus 1, where k is just some integer. Positive, negative, doesn't matter. Okay? Well, if that's the case, then we have 4 times 2k plus 1 plus 1. Right? So we replaced a with an odd number, something that we verifiably know is going to always be odd. Now what do we do? Well, we get 4 times 2 times k plus 4 plus 1. And I'm kind of overworking it here a little bit. But it's going to be okay. I can now take out a 2, and I get 2 times 4k plus 2 plus 1. Notice I didn't actually combine the 4 and the 5 to get 4 and the 1 to get 5. Well, left them separate. Because now what I have is I have 2 times something that I know is an integer plus 1. So by definition, this is odd. All right? So case 2. So this was case 1. And a lot of times in math, what we do is we create multiple cases when we know there's going to be multiple different types of outcomes. So we're just messing around with different values here until we find the one that really kind of fits best, right? So case 2, because there's other versions of this, a could be even. So it's 2k plus 1, where k, once again, is some integer. And I guess notation-wise, what we're doing here is this e-looking thing, this little c with a dash in it maybe, depending on how you look at it, is the mathematical symbol for belongs to. So we're literally saying k belongs to the set of integers. An integer z with the second bar in there is your universal mathematical symbol for integers. Okay? So, now what do we have? Well, now we have our original expression here, 4 times 2k plus 1, right? Well, what is that? Well, that we can just use our commutative property and switch those two, right? Or I could just split 4 up, and I can make that 2 times 2k plus 1. This is not the only way you could expand this expression here. But now what do I have? Once again, I have an even number plus 1, right? I have 2 times something, which this whole section right here is once again even, plus 1. Even plus 1 makes it odd again. So 4a plus 1 is odd, always, right? Now, in math, normally when we finish some type of proof, we're done showing something. A lot of times we end it with something traditional. A lot of times the textbooks will have QED, which is Latin for essentially what was asked to be shown. A lot of times in modern text, you'll see a box that's kind of filled in like that, a little square filled in. I actually like to do BAM. It's just more fun, right? But it doesn't really matter as long as you do something at the end to denote that it's over with. Just like you with a sentence, you put a period at the end. All right, so this was a pretty simple one. All right. So now the next question is, well, let's look at something a little bit more complex. Let's say that we're talking about a plus b. squared. Well, in this case, I'm actually going to have to do something a little different, because now I'm not talking about a single unknown quantity, right? I'm looking at multiple quantities, and I'm wondering what all those values end up being, right? In some cases, we can have more than two cases. In some situations, we need more than two cases. And we'll just kind of look through this and see how many cases do we need. Case one, obviously, is we need them, maybe both are odd. So A is equal to 2k plus 1, B is equal to, and this is the thing where we have to be careful. We can't reuse k, because B and A aren't necessarily the same quantity, so we just do 2k plus 1 again, we're implying they're the same quantity. So we want to make sure they're different, so we're going to call this 2m plus 1. And here I'm going to say that k and m are some integers. Now, I can just plug these things in. The thing I want to remember, though, is a plus b quantity squared is equal to a squared plus 2ab plus b squared. Depending on what form we're working with, one of these two forms might be easier to deal with. And since we have more stuff here, it might actually be easier to deal with it in the right-hand version of this as opposed to the original version. So we have our factored form and we have our expanded form. I'm going to use the expanded form here to work with that. Okay? So what do I have? So now I have a squared plus 2 times a times b plus b squared. All right? So let's do some simplification, because remember what we're looking for is, do I end up having an even plus 1 or do I have an even? Because that will tell me whether it's odd or even, right? So let's expand this piece out, which gives me 2 times 2k squared plus 2 times 2k and then plus 1. That's that piece right there. Now, if you need to do this out, I'm just kind of quickly going through this. There's a lot of algebra going on here, but pause the video, work this out on your own to make sure you can verify the algebra here. Okay? And I'm going to preface that with, I am human, so occasionally I do make a small mistake here or there. I'm not going to do anything to this second piece. I'm just going to write it as is. It's 2 times stuff, right? I don't even have to worry about what's here, because this is an integer, that's an integer, right? These two things in these parentheses here are integers. So 2 times an integer is even. So what I have here is an even number. So that's done. And then here, this actually repeats exactly what I have there, except with m's instead of k's. So I have 2 times 2m squared plus 2 times 2m, and then plus 1 again. Now, it may look like on the surface we're just making this more complicated, but remember, I need to get it in the form of 2 times something or 2 times something plus 1. Well, I got 2 times all this stuff, I got 2 times all that stuff, I got 2 times all that stuff, except I have these 1s here, right? So I have all of this stuff. Sometimes I have that right there. Oops, I went too far. Okay, I have that right there, and I have this right here, and this right here. All that stuff is 2 times something. And then I have plus 1 and plus 1, which gives me plus 2. So what I have is 2 times a whole bunch of stuff plus 2. I can rewrite all that, and I probably should. But for the sake of this video and time, I'm just going to say, hey, look, I have all this stuff times 2. That's even. Plus 2, which means now what I have is 2 times a whole bunch of stuff, right? And right here, there's a plus 1 right there. Because I have 2 times this stuff, right? I have 2 times everything inside the parentheses, but now I can factor 2 out of both of those things. So I have 2 times all that stuff, right? We'll call this stuff, right? Truly mathematical terminology there, right? And now what do I have? Well, now I have 2 times a thing, which means that this is even, right? So that's the first process. That's case one. What other cases am I going to have here that I need to work with? I have case two, where they're both even, right? So that means that A is equal to 2k and B is equal to 2m, where k and m belong to a set of integers. I don't necessarily have to rewrite this piece, especially if I declare it at the beginning over here before I do anything else, right? So I would then do that work just like I did here. And it's actually a simpler process because I don't have all the plus ones, right? And then I need to do another one. In this instance, by the way, it's actually probably easier to use factored form, okay? But that's up to you. And then we have case 3, where they're different, where A is equal to 2k and B is equal to 2k plus 1. Not k, I'm sorry, 2m plus 1, right? So that's 2m plus 1. Well, that works, right? What about case 4? Case 4, I have A is equal to 2k plus 1 and B is equal to 2m. Now the thing about case 3 and case 4 is they're essentially the same thing because A plus B are nondescript to begin with, right? They're interchangeable. We don't know which is which and we don't care. And addition is commutative. If this was A minus B, we definitely have to have case 3 and case 4. But here we're doing addition, so it's not going to matter. So I don't have to do case 4 because case 3 would actually take care of everything. So I do case 1, 2, 3, and 4, and I end up with what the results are. So I might end up with one version being even, one version's odd, another version's even, another version's odd. So I go back to the beginning here, is this even or odd? The answer is it's both, right? Or it's just, like here, it's just even. So if everything else worked out to be even, I'd say it's just even, right? So I'd work through those different cases and see what we get. And really, if we get to this spot right here and we find that it's going to be odd, we don't necessarily have to do case 3 because now we know it's even sometimes and it's odd sometimes. But we do actually want to go ahead and do this thing to know when it's even and when it's odd. We know if the answer is just, is it even or odd, we'd be done after we found that it's even and it's odd. If we don't want to know when it's even and when it's odd, we need to do this last one as well to get that taken care of. Okay? Well, I hope this was useful. I'm going to leave it to you to finish this out. It's a good practice for you to work on. And I hope this is understandable. I hope this is useful for you understanding how to do a little bit of proof. I mean, a piece I didn't put up here was, this is me starting a proof right there, right? So, and this over here would be me finishing it, right, when I get down to the bottom and I've done all the other pieces of this. Okay? So take care, and happy mapping.